We will move on to another one of our extension colleagues, Dr. Ben Spong, sitting there. I see you up there, Ben. And tonight, Ben is our forest operations extension specialist. And so he does all things, timber harvesting related. He teaches a timber harvesting class here at West Virginia University and is also our, most proficient expert on technology in the natural resources group here. So he's going to tell us a little bit about this mapping program, digital mapping program, Avenza. So Ben, please.
Great. Well, thank you very much for having me. It's been a little while since I've participated in this program, and it's great to see how awesome that how awesome the participation is. It's really really fantastic. So I'm going to talk a little bit about a software program called Avenza that we are using at the university, and I know land managers around the country. The Forest Service has a contract with them. A number of private forest management companies use this software. And it's also a fantastic tool for landowners, loggers, and anybody that sort of recreates outside. And so I wanted to share sort of a little overview of the software and maybe give you a push to download it and give it a try on your own property. So let's start here. So imagine having the forest's entire story in your pocket. So what if you could walk your property and you know instantly where you are on that property? That you could mark all those important spots that you wanted to visit with a simple tap. You might be able to show your forester or logger or a colleague some precise locations without having to do a bunch of paperwork or guide them with a bunch of verbal words. If you wanted to track timber, wildlife, land changes, all of this information over time, all of this can be done in your pocket now to help you make smarter, more informed decisions as you manage your forest lands. The tool that we're going to talk about is one called Avenza Maps, and I'm going to call it your personal land navigator. Avenza is a mobile app that turns your smartphone or your tablet into a powerful land management tool. It has very specific features that are really, really powerful for outdoor professionals, landowners, recreationalists, anybody wanting to use maps and GPS technology together. Some of the key benefits of this software is that it works regardless of cell service. So if you're in the radio quiet zone over in Pocahontas and parts of Randolph County, this will still work there. As long as you've downloaded your maps ahead of time, it's really going to provide you that constant ability to continue working even without a cell signal or without a data coverage or data plan on your phone as well. It's a really simple program. There are some more complicated things you can do in it, but on its surface, it's a very simple and easy for most beginners. People that claim they don't know anything about computers, oftentimes they can still do enough of the things in Avenza to get real value out of it. On that same note, it is powerful enough for professionals. Like I said, the Forest Service has a contract with them. Lots and lots of land management agencies and organizations use this software to share information and use their maps out across their land ownerships. And in the end, this app basically transforms your smartphone into a high-tech land management tool that really can help you better understand your property and communicate that with people that help you manage that actively or over the long term. So some of the common issues that we see when we're dealing with forest navigation and walking around in our forest woods are that our paper maps, they're big, cumbersome, easy to rip, they get wet, they get dirty, they rip. And You know what? Most of us, we claim we know how to use a compass, but many of us have forgotten how to use that compass together with the map. And a lot of us have a lot of difficulty finding out exactly where we are on that map and on the ground, and making sure that those match up so that it's easy for us to understand all of the information that's out there. We also might need some additional tools and equipment. And again, it's hard to communicate different issues or locations or situations between different collaborators using our paper maps. And so what Avenza does is it provides us this opportunity to kind of meld those paper maps together with sort of this modern technology. Its core features are that it has the GPS location tracking, and so very similar to the one that might be in your car, or Google Maps or Waze or Apple Maps or whichever ones that you might use in your car. It's it's using that same GPS chip that's inside most of our modern mobile devices, but it can do that without cell service, without a data coverage or anything there. So you don't need to worry about having a signal. You can import and export maps and data that you've collected or that you want to view into the app, and have that available at your fingertips for use in the field, or once you're back in the office or back at home, to be able to use those data to help inform and make decisions on your property. It also provides this coordinate system and allows you that opportunity to mark and share waypoints and tracks and a record of where you visited on that property. The core to Avenza is what they call a geo-referenced PDF map. And that's a big word, but some of the stuff you might recognize there. So PDF is a file type for a digital, it's portable document format is what it actually stands for. But pretty much any form that you've received from anybody, your tax forms or your anything that you get online, most of it is in a PDF format. And so it's a very common format that many of us are very familiar with using, opening, and interfacing with. The special thing about a geo-referenced PDF is that there's geographic coordinates that are attached to that. And so the image that would be on that PDF file has a coordinate at the top and the bottom, and that tells it where that map or that image rests geographically in the world. And so it has that spatial reference system information embedded onto that file. You don't see it until you open it up into with a program that knows how to interpret that. So, but with that extra information, you get precise location tracking, you get accurate distances and area measurements. You can integrate it with other GPS and mapping softwares, and you can also use this offline, like I said before. It really helps us bridge that idea of a paper map and sort of this new digital mapping technologies. So there are lots and lots of sources for maps, and so sort of different than maybe Google Maps that you may be familiar with using for figuring out how to get to the restaurant at night. Avenza has some base maps that are new right now, so it's a sort of a new feature. And so some of that base maps will look very similar to a Google Maps type situation, where you can scroll in and zoom out and move your way around that map. The base maps are not loaded into your phone, and so you do have to have network or data coverage to have access to those base maps. So those are there if you need them and you have data coverage. But the real magic of Avenza is that it allows you to import those geo-referenced PDFs. A lot of those maps are available directly from the Avenza Map Store. And at the Avenza Map Store, there are lots of free and paid maps. So many of our state, federal, community organizations provide their maps on the Avenza Map Store for free. And you can click on it, download it when you're connected to Wi-Fi or when you have data. And then that map rests on your device. And then you can use that for navigating, for collecting data, or whatever else you want to do. Some other places that you might see some opportunities to get maps, the West Virginia GIS Tech Center and many of the associated state agencies that use their data have PDFs on their sites that will allow you to look at the tax parcels. They'll allow you to look at all sorts of different things. And so you can dig through their stuff. Some of their stuff is not organized, super user-friendly, but it is there and available and is a great resource. You can create your own PDF maps using GIS. And so if you have access and knowledge to some GIS technology, like ArcGIS or some other programs, you can create your own custom maps with points, with whatever data you want displayed on there. And it basically is saving it as a picture that you can then load in georeferenced into Avenza. This is sort of advanced use and maybe not appropriate for a lot of our landowners. But if you're working with a forester or working with a timber company, a lot of these organizations have robust GIS programs, and they would maybe be able to provide you some of those georeference maps that you could then bring into Avenza to use on your property. And again, the Forest Service, almost all of their maps are georeferenced, and you can pull those down from online, from their websites, from anywhere that you find them online, or you can also get them, many of them, straight from the Avenza Map Store. And we'll show you how to do some of these things here in a second. So how might we use this? So as a landowner and a land manager, some of the things you might want to use Avenza for is mapping and inventorying your property, finding those spots, those plot centers, being able to go back to those year after year, or to, depending on how you've set up your inventory, you may have a certain spacing, and you should be able to measure and get those laid out on your map real easily there. You might have some planning in operations. If you're going to carry out a timber sale, maybe you want to make sure you understand what the acreage is in a very precise manner. Maybe you want to understand where those property boundaries are. And so a lot of these things can be done using some of these maps and the Avenza tools there. And then finally, it really works well for collaboration and communication. So if you have some sites that are either no-go sites, I don't want anybody coming anywhere near this, or places that I really want to make sure that my road goes through this way if I'm building a new road, I can communicate those points and those coordinates very easily using Avenza and export those and share them with my forester, with my contractor, the logger, anybody else that might be helping me out with the management of my property. Sort of outside the landowner and land manager uses, it also is amazing for hiking, fishing, hunting, urban exploring. Anytime you need a map and you want to know where you're at, this software can really help out on that. And the fact that it works when you're not in a data coverage area and really far away from the grid, it's really a really handy tool. So I'm going to give you a quick little demo of this and try to answer some questions as we go along here. But on the right-hand side here, you'll see sort of a screen capture of one of the maps in there. And so we're going to go over how to load a map there, how to find our current location, and then creating place marks, and how to use some of the basic navigation tools. So I'm going to put on my live version of this here. And so when you first open Avenza, actually, Dave, can you see the app on top there?
Yeah, Avenza Maps, My Maps.
Yes. Okay, perfect. Just want to make sure that shows up. Okay, so with this, this is the screen. When you double click the app on, this is working on a Samsung Android powered phone right now. If you're using a tablet, you know what, the screen's a lot bigger and it looks a lot nicer. But this is on my phone. And this is using what we call the free version of this. So there's no charge for any of the things that I'll show you how to do today. And so first thing that we might want to do is load a map. And so the easiest way to do that is to go down to the bottom where it says store, and I can click on store. And then it's going to help me find a map. If I have some keywords, I can type those in. I can also explore on a map. I like to use this little filter button or this little funnel here. And with that, I can make some selections. So I want the ones that are closest to me, and I want ones that are free. I don't want to pay anything. And so now if I hit show results, it'll show me all the maps that are close nearby me and are free. And I can take a look and see if any of those are of interest to me. So in this case here, I have the Morgantown North topographic map. I have the topographic, well, this is the image-based topographic map. And then I have the actual USGS quad map here. And I have a number of different versions of that. I have a Cheat Lake fishing guide. I have Osage. And so you can see that a lot of the USGS maps that you might be familiar with are already preloaded in here, and you can access them. And so if you're interested in one of those, you basically click on the free, and it will download and it'll come into your My Maps area, into your library. And so I already downloaded the Morgantown North quad map, and I'm up here in Morgantown, and it says that I'm on the map. So my GPS on my phone recognizes where I'm at, and now it has placed me on my North quad map of Morgantown. And so if I look here, I clicked on the map, and now this is the interface for the map here. And now I can click on this little symbol up at the top, and that's going to center the map with where I'm at. And so I'm sitting here. And now I can scroll around and go look at other parts of the map and see those places. Now, if this map isn't really handy and I prefer one that has an image behind it, I can go back into My Maps and I can look at the one down here. I downloaded this one as well. And so now I have the image that is on that map, and I can use that map as my base map. And again, if I click this, it's going to take me over to my location, and I can then do whatever I want from there. As I scroll around, you'll see this little target in the middle here. And that circle with the target around it, that is the center of the map. And that is going to be where any point that I wanted to collect. So if I wanted to collect a point over here at the end of the road at this little pond right next to Mon General Hospital here, I can get right on top of that. And I can click on this little symbol here, which will then mark my place marker here. And here I can type in a name, so pond. I can change the color. I can make it look like an ATV. I can get my exact coordinates for that location, my elevation, and any other information that I wanted on there. I can also, if I was collecting information for, like say, an inventory plot, I could actually write some notes here. So I could write red oak, 24 inches DBH, 3 logs, or any other information that I would want there. And now that is saved with that point that I saved there. The other thing that I can do here is I can take a photo. And so I can add a photo. I click the little camera here, and it's now gonna, now looking at my ceiling. I can take a photo, and it will then add that photo right to my Avenza information, and it will put the geographic information associated with that on there and include that in my data. And so when I'm done, I can hit the check mark, and it is saved and ready to go. Now I can use tools like these basic navigation tools down here on the bottom left-hand side of the screen. I can click this, and now I can navigate to a destination. Now that I have that destination over at the pond, I'm going to navigate to that feature. And now I can navigate to that pond. And now it's going to give me a map and some directions on which way I need to travel in order to get there. And so as I start walking, it'll tell me, it'll update my distance, it'll take my speed, tell me my time to get there, and what bearing I need to go, and if I need to follow that. And it'll update that in real time. If I take a left and I'm supposed to go right, it'll change directions and keep pointing me in that right direction that I need to go. So very handy tool for collecting point information. The other thing that you can get is if you pull up here, you can get your actual location. So here's my current location, my speed, my altitude, what is my accuracy, both vertical and horizontal. And so you can get a lot of other information here as well. So those are some basic tools that we can do for doing some navigation. If we were going to collect some data, we could do that by adding place markers, which I already showed you how to do that on the previous slide. We can also create areas like you see over on the right-hand side. So here I basically created an area around the farm woodlot here out on West Run Road. And by creating that boundary there, it will figure out what the perimeter length is and an area of that, and I can change the units of that and all sorts of stuff. But very simple to create an area and to measure distances and other things directly in the app to help inform you where you're going. The other thing we might try is recording a track. And a track helps us record linear features. So if we're driving a road or walking a trail, going up a stream and wanting to mark exactly where that's at, we can hit the track feature and record that track. So here, if we go back to our map here, and if I wanted to record a track now, I can come back here and I can record a GPS track now. And so now when I start tracking, every 2 seconds, or when I move 7 feet in horizontal distance, it's going to take an automatic point, and it's going to keep doing that until I hit turn off or stop tracking. And so with that, it's going to create a line feature on my map and will help me sort of locate exact locations of my roads, trails, streams, or whatever else that I'm following on those linear features. Our point data is those place markers, and those are going to be more static locations. So those might be places like a soil pit or a tree, a stream crossing, a monument, other information that has a static location that you may want to come back to at some time in the future, or that you want to accurately mark on your map. And then finally, once we collect all of this information, I can actually come in here to this bottom right-hand corner, and I can then export this information by clicking these 3 dots next to the layer that I'm working with. I can go ahead and export those, and I can choose different formats from KML, CSV, GPS, and then even GPKG and shape files, although those 2 are only available on the paid version. So most of the time for our classes and for work that I'm doing, we're only using the KML feature there, which is a free version, free format that is available through Google and can also import into GIS and to other software. Okay, so almost done here. So we'll get out of the tech stuff here. But so some of the forest management applications, we can use this to identify boundary lines. And I will put a big caution on this. This is not survey quality. You should not reestablish unknown boundary lines using software GPS like this here. You would definitely want to hire a surveyor to find out where those legal lines are there. However, there are a lot of times when you want to make sure you're getting close to that boundary line, so that maybe if you're falling timber on your property for firewood, I can set up a alert on my Avenza that says when I get close to the property line, send me a text that's there, send me an alert on the map, and it will beep at me and say I'm getting close to that boundary, and that'll get me to think and make sure that I'm looking for those blazes and other markers that might be on that property line. Timber harvest planning, it's great for establishing where you might want to put roads or skid trails, SMZs, measuring the widths of different areas like that. Perfect for that. Wildlife habitat mapping, if you're putting in food plots or small ponds or water sources, this can help you identify where those are on your property and get those marked accurately on your map. Inventory plots, of course, and even fire management. If you're trying to see how much area was destroyed in a wildfire, you can quickly traverse that with the Avenza tools and collect that information. So it does integrate with other tools, easy to share with your collaborators. You can export it to GIS. You can import information from GIS. There are a lot of other kind of compatibility with common forestry tools and with collaboration features in some of the paid versions of this. So just to let you know sort of what the options are here. At the university, we're only using the free version, and we can do almost everything that we need to do, and it will probably work for most people. If you're doing a lot of collaboration and a lot of work with other folks, the Plus and the Pro versions might be worthwhile, but take a look at what those services are and the additional value that you might get from those. The biggest limitation of the free version is that you only get to have 3 offline maps. So if you have a bunch of maps that you want to deal with, you're going to have to delete one and add in the next one. And that can be very annoying if you have lots of maps that you're working with. The other issue that I think is a bigger problem is the collaboration with no map sharing directly. You can share the data, but you can't share the map directly. And not being able to export directly to GIS. You have to jump through a couple extra steps. But in general, the free version works great. And I've been super happy with doing that, although I'm tempted to get the Plus one now. So to get started, you can get Avenza through both the Apple and the Google App Stores. You can then get maps through Avenza, their map store directly in the app. You can get it from ad agencies and organizations from their websites. You can make your own maps in GIS. One that I found today is a website called CalTopo. This can help you create your own maps. And I thought it was a really slick site that allowed you to do some really interesting custom maps and looks at a whole bunch of different topography and different types of maps that are integrated in there and cover the entire country. If you wanted to learn more about using Avenza, there are thousands of YouTube videos out there of people telling you how to do different things. And so just type Avenza into YouTube and watch a couple of these videos and you'll be good to go. Give this a try out in your backyard or further afield into your forest lands. A lot of people in forestry also use another software called OnX and OnX Hunt. And those are sort of competitive type programs or applications. But Avenza really is more focused on, or not focused, but it has a lot more uses for natural resource management and forest management. Whereas the Onyx and Onyx Hunt, some of the has some of the property boundaries and some of the tax map information already built in there, but it doesn't always allow you to collect the same sort of information. It doesn't allow you to make your own maps, and it's maybe a little more limited in some of its uses, but it definitely has some places. And I would recommend, if you like Onyx, give Avenza a try and see how it works for you and see which one you like better. So that's the quick overview of this. There's lots more details, and the more advanced features of this can get pretty complicated after a while, but on the surface, it's very, very simple. It puts a dot on a map that you've uploaded there. It works offline, and it helps you understand where you are and collect information right at that spot. And so with that, I'm happy to answer any questions, and I'd be actually interested to know if anybody is using Onyx out there on their own property already.
Yeah, I tried to download that thing, and I have to get my password to get into the Apple Store or something to approve that. But yeah, so it's both Android and Apple available, right?
Correct. And it also works on tablets. And so if you have a poor eyesight like I do, the tablet gives you a little bigger screen area, and allows you to have a little more space to view. Caveat to all of this is that it is a software product, and it runs on your phone. And when your battery dies and you're out lost in the wilderness, it doesn't do you much good to get back to your car or get back home when the battery's dead. So make sure that you have either a portable battery to keep things charged, or make sure that you have a full charge going out, and don't expect to overtax that battery during your use.
Mm-hmm. Yeah, Kyle Aldinger is saying he uses it. It's easy to use, our NRCS colleague there. And then Claudia's asking, when you record a track, does it also record elevation as you move along?
I'm pretty sure it does. I don't know for certain. Yeah, I'm almost positive it does. And it, because especially when you export it, it will allow you to see the elevation on that as well. So I'm 99% sure it does.
Yeah, I guess there's some users out there. Brian H is saying, I'm a fan of Avenza. I went for the plus version. It's well worth it. And then Ryan with All Star Ecology saying, when making custom maps in GIS, make your page size very large to have better resolution in your map. When you zoom in Avenza, I often make 22 by 34-inch maps for Avenza.
Yeah, absolutely. When you're exporting from ArcGIS, yeah, choose the biggest paper size you can. All of a sudden, sometimes those files will get big, but I don't think I've had any problem loading even very, very large size maps into the software. And like I said, our students are using this, so we're working with our students to use this tool as one of their ways to navigate through the forest to collect data. And I think the great thing about it is that most of us have a smartphone already. We probably are carrying it in our pockets already. This isn't a separate device. It's not something you have to learn differently. And it's just super user friendly and like any other app on your phone. So I think it's great. And so give it a try. And if you have questions or you want more information about it, feel free to send me an email or contact me, and I'm happy to chat with you about it more.
Yeah, these apps seems like, maybe with a big company that wants to integrate their inventory system with a bunch of foresters working for them, that would be something different. But if you're an individual and need mapping to, power, these things seem to be really helpful.
Absolutely.
All right. Well, I think that's it, Ben. We appreciate you coming out and sharing that with us. That's a new one to me because I have not used that. And thanks so much. Good to have you here.
Pleasure.
Right. And with that, I'll just come on here. So it's great to have you, Brian, and take it away. Floor is yours. You should be able to unmute there. There.
All right. Can you hear me now?
We can hear you. Yes, loud and clear.
Yeah, I'm trying to share my screen. Can you see my screen?
No, it just disappeared. So go ahead and try and share it again. And we see your PowerPoint application. And if you start the slideshow, it should come up. There it goes. Perfect.
Excellent. Well, I'm Brian Carr. I'm the program manager for the Source Water Assessment and Protection Program. We're part of the Department of Health and Human Resources, and we are under the Office of Environmental Health Services and the Environmental Engineering Division within the DHHR. So I manage the Source Water Assessment Protection Program and the Certification and Training Program and the GIS program here at the state. So if I can. So our Source Water Protection Program general responsibilities are to review and approve the public water system source water protection plans. We maintain a wellhead protection program, manage a grant program for the public water systems that have to do source water protection grants or plans. We assist the permitting of groundwater systems for their geothermal and public drinking water wells. We oversee the geographic information systems that for data sharing and such for public water systems and the public and other state agencies. We maintain internal partnerships and we participate and fund a number of scientific studies for groundwater and hydrologic study across the state. So, real quick, program history. We started out back in '86, and that was when our program was developed. We did voluntary source water protection plans from public water systems through 2000 all the way to 2014. April 2014, we had an Elk River chemical spill, which affected our water system in Charleston, West Virginia. So, with that, our legislature actually enacted the requirement to do source water protection plans for public water systems, and that's via these codes at the bottom of the screen. So as of 2016, we reviewed and accepted 125 public water system plans. We added 19 in 2020 for systems that were groundwater systems that are influenced by surface water. And currently we have 144 plans that we are reviewing that have submitted and updated their plans every 3 years. So when we talk water and drinking water, we have to talk about the West Virginia aquifers. A large percentage of our water systems and about 40% of the citizens of West Virginia get their water from groundwater. So there's a number of different types of aquifers in our state. The largest one, of course, along the Ohio River, which is an alluvial aquifer. They produce a huge amount of water. It's just the water that's in the sand along the riverbanks. We also have fractured bedrock aquifers. Now, these are in the higher elevations and such, and the water travels through the fractured bedrock. Those are usually produces quite a lot less water than your alluvial aquifers. We also have karst aquifers, and we'll talk about that a little bit more in a minute. And those karst aquifers are in limestone. The groundwater flow is always dependent on the size of the fracture, and that's whether it's in the fractured bedrock aquifer or within the karst aquifers. We'll get a little more into that in a second. So alluvial aquifers are basically just that sand layer that's underneath the river that has been laid down over a long period of time. People sink wells into that loose clay, silt and gravel and sand, and they can pull vast amounts of water through that sand layer. The thing is, sometimes that's influenced by the river water that's right above it. Sometimes you get further enough inland, you can get into some alluvial aquifers that don't have as high of influence of surface water. And the reason that that's a concern to us is if you get a large influence of that river water into that groundwater, then the contamination that's in the river can reach your well. So we have to be concerned with that. Now, karst aquifers, they're basically caves, caves and the conduits that are formed within the caves. It's a dissolution of limestone and other carbonate materials, and it produces things like springs and sinkholes on the surface. We have a lot of karst systems in our eastern panhandle, and then we have another whole batch of them down through the Greenbrier area watershed. So concerns for source water for karst obviously are that the water can travel great distance underground really fast. And in West Virginia, when folks find a hole or a sinkhole formed in the ground, they typically throw cars and washer and dryers and things down in it. And once the water and the storm water runs off and comes through all of that material, it's directly transported down into the karst system. Folks will sink their wells down into that karst system or right below it, and then anything that's in that karst aquifer through those sinkholes or even drainage and seepage from septic tanks will get down into that karst aquifer, and then you'll just pull it right back up into the water system for your home through the private well. Now, we have a little bit of a unique situation in West Virginia that other states do not, and we've actually named our abandoned coal mines abandoned coal mine aquifers. There's more water in our underground coal mines than we have in our surface lakes in our state of West Virginia. And a lot of them in southern West Virginia are very high quality pools of water, and they're enormous. And we have a lot of public water systems that sink a well into those mines and treat that water for potable water. It's a very good source. Now, some of our northern coal mine sources are not so great. They're in Pennsylvania seams that have higher levels of iron and acid and other such things in it that don't make it so available for public water supply. So, as I mentioned before, our source water protection program reviews and approves source water protection plans. So the submissions of plans are submitted to our office, and they have this variety of different things you can see on the screen that are required to do. Basically, a source water protection plan is the ability for the water system to prepare and handle a contamination or an emergency event like the chemical spill we had, or the recent train derailment in Ohio that affected our Ohio River water. We have trailer trucks and such that go over rivers. And this is in order to be prepared to handle those types of emergencies, know the communication of the folks that you need to talk to when that happens, how they're going to get out the information to the public, and whether they can close their intakes and how much water they have on reserve and all of that. So all of that is included in their source water protection plan. And we review those and make sure they're complete with all of the items that are included in the law within the West Virginia Legislative Act 16.1. So we created a online portal for folks to enter their plans and to update their plans to make it a little easier. As I said, this slide shows 141 public water systems. We now have 144. The number changes when some folks will overtake plants, they'll combine, or we even get some new systems occasionally. And if we develop designate one of the public water systems as a groundwater influenced or surface water influenced system. This we approached the legislature a couple of years back, and they have allowed us to accept the plans in groups. So we staggered the submission of the plans. We created the regions, their groupings of hydrologic watersheds. So those 1, 2, 3, 4, and 5 regions you see on the screen are separated by about 7 months each. So every 7 months, we get a new group of plans that we review and get approved, and then continue on with the next group of plans that are submitted. Now, for the folks, the public water systems that are submitting those plans, our GIS program provides them with a number of different delineations and information. We provide them with a 5-hour time of travel model, which is called the zone of critical concern. And it's a zone that comprises 1,000 foot from each bank of the main stream and 500 feet from each bank of the tributary stream. And if a drop of water hits at the top of that red zone, it'll take 5 hours for it to end up down at the intake. That 5-hour time of travel is based on the bank 4 high flow within those streams. So that's the worst case scenario. We also delineate the entire watershed for that water system. So anything within that watershed has the potential to eventually get to the water intake. We are also required to do a zone of peripheral concern, which is another 5-hour time of travel. It's pretty handy if you go to the middle of the ZPC, you've got 7.5 hours before a contaminant that's spilled there will get to your intake. So it's kind of a quick look for time of travel through the streams to your intake. So with GIS, we have created a mind map portal, and it's available to the public. One of them is, and we put a whole gamut of different different layers and such on there that are important to public drinking water. We also show on that site the wellhead protection areas. So currently there's about 820 active wellhead protection areas that we've delineated around groundwater wells that are used for public water systems. And those areas are all portrayed on that GIS website. We have a confidential website that we allow for the public water systems to look at that puts all the abandoned mines and some other confidential information out there. We have the public version of this site, which also allows folks to see things like coal mines and MPDS permit outlets, sewer outlets, and things of that nature. Both of these systems have an attribute table where you can look up all the information that we have on there. The confidential website that's only available to the public water system, that site has US EPA Tier 2 sites, the big fuel depots and things that are not public information, above ground storage tanks with the contaminants that are in them, underground tanks and leaking underground tanks. So this site is held confidential, but the water system can look up any kind of contaminant that's in their general region, their ZCC or ZPC, that they could be concerned with, and they include those lists of those items in their SWAT plan. So we encourage and we fund water systems to do tabletop exercises, which are basically response exercises for spills, for any variety of spill. We've done upwards of 20 of those in the last 5 years. So I was asked to talk a little bit about some of our projects that are ongoing right now. One of the projects that we have just completed, we're anxiously awaiting a report, is our alluvial aquifer study. So the overall purpose of the study was to determine the groundwater quality in the alluvial aquifer along the Ohio River Valley. It included looking at 4 surface water sites and 23 groundwater wells. They averaged anywhere from 20 to over 2,000, over 2,500 feet away from the river, and typically we're anywhere from 50 to 100 foot deep. So the general principle within an alluvial aquifer is the water from the river, as I mentioned before, can travel down through those alluvial sediments and into the well that you're pumping through, which also intercepts the groundwater that's flowing towards the river. So, um, uh, so we evaluated the Ohio River water samples and all the groundwater samples for a large variety of different analytes. As you can see in this list, we looked at VOCs and semi-VOCs. We looked at pesticides and herbicides, a lot of ions and trace elements. We did a lot of geochemistry and that type of evaluation, looking for a number of things. We were really looking to define the variability of the aquifer's water quality along the whole Ohio River Valley. Wanted to identify the controlling factors on the geochemical evolution, basically looking at water age and trying to identify if we could find a signature for the actual surface water in the groundwater. So we're looking for percentage of river water that was actually getting into that groundwater well. We have to determine if the public water system is a SWIG, which is a surface water influenced groundwater system. And that's exactly what that is. If it's influenced by that surface water body, then it's a SWIG. Before we did this study, we had no way to identify any of that using geochemical analysis. Well, we learned a lot. We learned a lot about the surface and the groundwater. But one of the things we learned that was interesting that agrees with some other studies that we've done is the groundwater in the state of West Virginia is relatively young. It's not any more than 60 years old, which means that 60 years ago, all of the groundwater was on the surface somewhere. So we also learned that we do have a geochemical signature for the amount of Ohio River water that's in the groundwater along that Ohio River Valley. And that basically we determined that there's a linear a linear signature of sulfate and bicarbonate, which is specific to either groundwater or surface water. So you can see the groundwater, the red dots, they have a higher percentage of bicarbonate, and then the surface water has a higher percentage of the sulfate. So those samples that fall in between that are a mixture of the two. So if you've got a one of these well samples that falls dead in the middle here, that's nearly 100% of the surface water versus groundwater. So by testing that and plotting those results, the last column over here on this chart is the percentages of all of these sites that we tested of the percent or fraction of the groundwater sample that was actually surface water. So as you can look down through here, you had some that were 70%, 80% of the groundwater in that well that folks thought was groundwater is actually Ohio River water. We had a couple of them like Point Pleasant, which was pretty far away from the river, that had a very small percentage of the water in the groundwater that was actually from the river. So with this, we were able to confirm the 19 SWIGs that we had classified previously. So there's a lot on this slide, but this is a CDC study. It's another study we did. It took us 5 years to do this study. It was funded by the CDC for us to look at groundwater quality in the state of West Virginia for private wells. Basically, they had determined that the Appalachia were higher in morbidity for some of these diseases than other places in the rest of the United States. So the question the CDC was after was, is this a result of the groundwater that they're drinking in our state? So we took a look at that by sampling 60 private groundwater wells in southern coal fields and 30 private groundwater wells in the northwestern part of the Marcellus wet gas region of West Virginia. And we looked at these samples for 52 different analytes that are measured in drinking water and have been related to health issues. A lot of those include metals and bacterias and naturally occurring compounds and also biological stuff like E. coli. So that the EPA has a site online that we utilize and put our results for this whole test on, called the Be Well Informed site. And folks can take their water quality samples and get them tested in their well, and then they can go online and figure out what the results mean by going to that site. And we've put these major analytes that we identified in our state in the private well water on that Be Well Informed site for folks to go out and take a look at. So the water quality in the northwestern, really wet gas region of the state of West Virginia, we determined they had some issues with TDS, or total dissolved solids, total coliform, E. coli, iron, arsenic, and radon gas dissolved in the groundwater. We found really high levels of dissolved radon gas in that area. And that's not from the Marcellus shale play. It's from a near surface black carbonaceous shale origin from is where that water that radon in the water's coming from. But we found that it was pretty high in a lot of the results, and so we sent a bunch of free indoor air tests to the folks where we tested their wells, so they could test their indoor air quality. Basically, radon, when it's dissolved in water, it doesn't do anything, and you can drink it. But if it diffuses, like at the shower head or the sink faucet, then it can become aerated. And if it's aerated at a high enough level, then it can become a carcinogen. So basically, from this test, we determined that the water should be tested for those seven, I think, 6 or 7, 6 analytes. And the big plus is we determined that 46 of the total 52 questionable analytes were not an issue in that area. In the water quality in the southern coal fields, we again did a similar type of testing with the same number of 52 analytes, and we identified high levels of total coliform, E. coli, pH, manganese, iron, arsenic, sodium, aluminum, and radon gas. Again, however, the radon gas was much lower and less regular in the coal fields than it was in the northern gas play, which was pretty interesting. Not sure why that is. But again, we did define those as target analytes to be tested for in private drinking water wells. And again, we eliminated 43 of the 52 analytes that were of concern. So those would not have to be tested for in those regions. We have an ongoing project called the Geophysical Well Logging Study that we've been working on for almost 12 years now. We're hopeful that we'll be completing that up here in the next year or so. So geophysical well logging is obviously a technology that was developed for the oil and gas industry, where they would send a number of cable attached tools all the way down the well and pull them out and run different tests so you could figure out what the makeup of that the rock units were below ground, and basically find out which ones had the highest potential to hold gas. And so that's where the technology started. We started using it. We figured out we could use it for some groundwater modeling capabilities as well. So our goal, basically was to collect and compile this data for a number of different variety of information to determine some aquifer characteristics, and to use the data that we were getting to make some general assumptions about the aquifers across the state of West Virginia. So we also were interested in the fracture and fracture orientation of the fractured bedrock aquifers, where most of our groundwater runs and is connected. So we wanted to know what the characteristics and some other specific transmissivity values and things within those fractures are. All of this was unknown when we started this project. Obviously, the geology and the stratigraphy of West Virginia is really complex, so it takes a lot of work to do this. So basically, what we did, we ran a bunch of logs down these wells. We looked at 125 different wells across the state and logged each one of them. We basically ran the different tools down the well, and what that resulted in is some pretty interesting stuff. We're looking here at a acoustic televiewer log, which is basic what it sounds like. It sends out sound and creates an image. We also use another tool called a sonic televiewer, which does a similar thing. But if you consider this as the borehole, when you take a map of the world and flatten it out like they do, so you can look at it in the World Book, we've taken the borehole and opened it up and laid it flat from 0 degrees to 360 degrees. And when you do that with this televiewer log, you get these sine waves or sine curves across the picture, the red and blue here. And you can take those and measure those sine curves and do some calculations, and you can determine those are representing fractures in the rock unit. So we can figure out the direction and the dip of those fractures. And then once we know that orientation, location, and dip angle of that fracture, after running all these other logs that are in this list, we can come up with, for each well, we can come up with the type of rock the water's running through, the amount of flow that's coming through those fractures, the overall orientation of those fractures, and start combining those well logs and doing some interpolation between them and mapping out some information we never had before. So it's very anticipated results for this study that we're extremely excited to see. We should be able to really define the groundwater aquifers across the entire state once we finish with this study and a few others and put them together. Everybody's been hearing about PFAS. We've been neck deep in PFAS for quite a while now in our program. We started looking at it actually when we did the alluvial aquifer study back in 2019. Well, actually, that was 2018. 2019 came along, and folks started talking about PFAS. So they required us to do a PFAS study looking at the amount of the per and polyfluoroalkyl substances that are out in the raw water and that we use for drinking water sources. So we looked at 279 different public water systems who have intakes in both groundwater and surface water sources. We tested their raw sources for over 26 different kinds of PFAS. And from a result of that, we determined that, once again, it's no surprise that the Ohio River Valley's alluvial aquifers are highly susceptible to PFAS, because mainly that's where the biggest source of the stuff is, in the Kimmer's DuPont plant, and Also, because those alluvial aquifers are just those wells and intakes anywhere there are just highly susceptible to contamination. Um, Once again, it was a little surprising that over a third of our groundwater sites and only at one half of the surface water sites, mainly in the Eastern Panhandle, had the PFAS detections. Once again, the groundwater sites over there in the Eastern Panhandle are in karst aquifers. So once again, not surprising that stuff can travel pretty easily, but also there's some pretty big airfield bases over there. And one of the biggest contributors to PFAS is the aqueous film forming foam, or a lot of people refer to it as the firefighting foam. And that stuff has been extensively used at airfields. So found quite a bit of it in the Eastern Panhandle, a lot of it across along the Ohio River corridor. Um, didn't find as much of it in the other parts of the states. The interior southern counties, West Virginia, don't have a lot. It either suggests that there's not much contamination there, or that it doesn't travel well through the fractured rock aquifers. Don't really know what the more study to determine why it's not really shown up yet. Um, Southern portion of the state, we looked at all the coal mines, aquifers, and such down there. Found that there's a lot of sites down there that do not have the PFAS either, and that's another interesting thing. So, just would caveat both those with the need for more study. All the study results for both those studies were, well, for the raw water study and a study we're going to talk about in a minute with the finished water, are publicized on the USGS science-based gov site. Just click on there and you can download all the results. My program also, I worked with my GIS guys, and we created this map for just West Virginia, just for the finished water sites that we have tested. And we are posting the test results for each one of those. We looked at 37 finished water sites so far, found PFAS in 37, or found PFAS in 19 of those sites. And those are the blue water drops on the map. The EPA, I'm sorry, not the EPA, the West Virginia legislature passed the West Virginia PFAS Act, which has required the DEP and DHHR to cooperatively look at another 106 public water systems and test their finished water for PFAS. And once we do that, we're just getting that contract completed. So it'll be at least another year or so before we find those results. And once we do, we'll be posting them on this site as well. So what's this all got to do with forestry, I guess? Forestry is typically beneficial for drinking water because, forests clean drinking water up. But deforestation, of course, can produce a lot of sedimentation and things and cause some issues with our source water. And, if you get a lot of sedimentation, the sediment also carries along with it minerals and other pathogens, which can become an issue for drinking water systems. Well, in 2019, Virginia and the EPA formed the Virginia Forest and Drinking Water Forum, and they've had a lot of success in communication between the industries, between forestry industries and drinking water industries and regulation agencies. And we've made note of that. So in West Virginia, we decided it would be beneficial for us to start one as well. So a group of us got together, West Virginia American Water and DHHR, DEP, Department of Ag, Department of Forestry, Forestry Association, a number of watershed associations, and then of course some federal agency partners that the USDA, EPA, and NRCS, a few others. So we all got together and decided it would be a good idea to create a West Virginia forest and drinking water partnership, try to understand how the management of forest lands in West Virginia is related to drinking water protection, highlight some statewide programs and studies, and maybe opportunities to do some other statewide programs or investigations into the connection between the two, and of course to enable folks to collaborate to do maybe some other source water protection projects. So as a result, like I said, in 2021, we actually did create the West Virginia Forest and Drinking Water Partnership. Um, we we worked with US EPA Region 3. We got a representative from them that is working with us and the group of folks within the forestry and drinking water industries. In 2021, we got a group of partners together and we started looking into the how to make this happen. So in 2022, we did a kickoff webinar. We invited a lot of folks that we determined that we thought would be beneficial to be involved. EPA Region 3 paid Cadmus to facilitate and get the workshop together. So there was a group of us who got together and worked pretty hard through about a year to get that webinar put together. And then we had the webinar and we focused on basically defining the relationship and how to reach a bigger audience. So as a result of that webinar, we decided we needed to have an in-person group meeting. So we had one of those in April, just last April. We worked with EPA and Cadmus and West Virginia American Water, DEP, and us. We got together and had a 2-day seminar forum in person, Sutton, West Virginia. First day we went over and looked at the Gasaway water treatment plant and talked about water treatment and their processes and what they have to deal with. And then the second day we had a lot of talks from forestry experts and a couple drinking water folks and some of the regulation folks. Basically looked at challenges and opportunities and what we can do different. We did a mapping exercise to actually look at where the forestry projects were going on and if we had a good handle on that. And of course, noticed that we needed to work on some funding and collaboration. So the next steps of our forum, we're going to have another meeting here in early spring, I believe, is our next group meeting. We're currently working on putting that together. We've noticed through our last meeting we determined a few things were really needed. Number one, we needed to enhance our partner communication. We also decided we'd like to hire a partnership coordinator to really pull everybody together and be kind of a non-biased entity for the forum. So we're working to figure out who the host organization for that would be and how we'd pay them. And then, of course, we got to come up with our strategy and our mission and goals and expected outcomes for the whole forum. And then, of course, we're going to create some tools and things that we can use online to assist us in those goals. So with that, I'll take any questions or anybody needs any clarifications. This is my contact information. Feel free to give me a call or send me an email at any time.
Great. Well, thank you, Brian. There are a lot of questions. I think we're going to have to move on a little bit, but there are a couple I'm going to ask. Okay. So, and the first one is kind of down in the middle of those. Maybe you can spend some time after, as Heidi, our next speaker, signs on and stuff to get into the chat and take a look at those questions. But one of them is, what happens if you find an aquifer or wells that are contaminated?
Well, yeah, it's a problem. The main thing is to quit using them and find another water source. I mean, now sometimes certain contaminants can be cleaned up. You can do oil and gas separator units. You can do some aeration. If you've got things like PCEs and things like that, you can put in certain types of filtration systems that'll take care of the pollution. Some air strippers work, and then if you find PFAS, you can run it through a granulated activated carbon filtration system and things of that nature. So the big part is identifying it's there, figuring out if there's a treatment method to take care of it, and moving forward from there.
Wow, yeah. So just focuses the importance of keeping clean surface waters, right, and keeping things clean before they get down to a point that you have to either turn off the well or stop it or spend a lot of money to clean up the water that comes out of it. So thank you.
Yeah.
Hey, so one more other question. There's a couple of people that kind of asked this. Does the state have any programs where the testing of private well water can be paid for?
The state doesn't currently have that. Sometimes the health department will come out and work with you, try to get something. There is, I believe, a federal program through the EPA that can assist folks with the costs for testing, but the majority of the time you're going to find that it's going to be the private well owner's responsibility to pay for that water testing.
Right. Well, Brian, thank you so much. Fascinating. It's one of those kind of parts of the world that we don't think about a lot. At least in forestry, the best management practice for controlling soil erosion and sedimentation. That's a big focus on, like, especially timber harvesting and things. But a lot of people that live in these rural communities rely on well water. So although some folks are trying to promote within their own community, trying to get the public waters to come to their properties as well. So thank you so much for coming on, and good luck on the forestry forum that you guys have set up, and really much obliged for you coming out tonight.
Thank you all for having me. Appreciate it.
Thank you.